Good morning, and thank you for joining us. I'm Nat Cohen, the president of the Center for Climate and Energy Solutions, or C2ES. For those of you new to C2ES, we are a nonpartisan, nonprofit organization working to secure a safe and stable climate by accelerating the transition to a thriving, just, and resilient net zero economy. And it's a pleasure to welcome you to today's webinar, Reacting to Industry's Needs, Nuclear's Role in Industrial Decarbonization. Now, for more than a decade, C2ES has been actively involved in building awareness around developing policy for and getting that policy put in place for maintaining and preserving the existing nuclear fleet in support of all the benefits that that fleet provides in terms of low carbon, reliable energy. At the same time, we've also taken a strong interest in innovation and developing new clean electricity sources, including advanced nuclear reactors with the environmental reliability and resilience features that they can provide. Today's webinar will feature the Honorable Shelley Moore Capito, a senator from West Virginia and a champion of nuclear power on Capitol Hill, as well as a sponsor of the ADVANCE Act, which we'll talk about. We will also have a panel of leaders in industry from Dow and X Energy. Let me introduce Senator Capito. Senator Shelley Moore Capito was first elected to the U.S. Senate in 2014. She is the first female senator in West Virginia's history. After serving West Virginia's 2nd congressional district in the U.S. House of Representatives for 14 years and as a member of the West Virginia House of Delegates for 4 years prior, Senator Capito decided to run for Senate to be an even stronger voice for the Mountain State. She currently serves on the Appropriations Committee, the Commerce, Science, and Transportation Committee, the Rules and Administration Committee, and the Environment and Public Works Committee, on which she is ranking member. A lifelong West Virginia, Senator Capito was born in Glendale in the Northern Panhandle. She holds a BS in zoology from Duke University and an MEd from the University of Virginia. She and her husband, Charles L. Capito Jr., reside in Charleston. A bit of housekeeping. We'll try to leave some time at the end for audience Q&A and the discussion. Please submit your questions into the Q&A portion of Zoom. As I said, I'll start off with a fireside chat with Senator Capito, followed by a brief presentation and then the panel. So, Senator Capito, welcome, and thank you so much for joining us.
Well, thank you, Nat. Thanks for having me on, and thanks for the good work of C2ES.
Well, thank you for joining us, and thanks for all of your work in support of nuclear and so much else. So, to start out, maybe you can share with the audience what got you interested in nuclear energy. I think in particular, given that you represent West Virginia, which of course is the 2nd largest coal producing state.
Well, we have a great heritage of powering this nation in my state of West Virginia, certainly through coal, and now we have quite a bit of natural gas at the same time. We know that these energy resources are good baseline energy resources, but they come with challenges. And so I became very interested in nuclear because I feel that, again, our state can still be a reliant engine of energy for the nation, and to enlist our not just our workforce but our innovation in the state for nuclear energy. So I think a lot of it is captured by the fact that I am from an energy state, but also particularly where I am placed on my committee as ranking member of Environment and Public Works. Puts me right at the, I would say, the fulcrum of being able to move innovative legislation through on nuclear.
Terrific. Well, thank you. And as you know, one of the things we're going to be focused on in the panel discussion later is the use of nuclear for industrial applications. Often we think about it as a core part of the electric power fleet. But how is nuclear especially well suited to industrial applications in some of the harder to decarbonize sectors, such as chemical and steel manufacturing? And as well, given all that coal fleet, how do you think about the potential of transitioning and adapting existing coal plants to nuclear?
Well, there are a couple exciting things already going on. You mentioned that your panel is going to have X Energy and Dow. They will be using a small reactor for industrial use, with Dow obviously being a very large chemical manufacturer. We're excited to see how that moves along. And interestingly enough, I just toured a factory here in West Virginia that is going to be providing some of the graphite for that nuclear reactor. So you can see that our manufacturing base in West Virginia is going to be able to contribute to what we consider the new nuclear. And so also we were careful, and we're going to be talking about the ADVANCE Act, but one of the things I was especially interested in was taking our old coal sites for several reasons. Number one, there's a workforce. Number two, there's transmission in a lot of these for power, for the power sector. And many of these sites have or will be abandoned, or they already are brownfield sites. What a perfect place for a small modular reactor. It would use the workforce that's in place there, and it would also reinvigorate the economy of those particular regions that have had, in some cases, very severe downturns because of the loss of coal. And so also that is occurring now. There is a transitional project being done in Wyoming right now that is using or will be using a shuttered coal-fired power plant to then transition. TerraPower is doing that, and is one of the recipients of DOE's grant process. So we did incorporate that incentive into the ADVANCE Act because I think it will spur investment. And also, you know, we do have problems with transmission. Now I'm not talking power sector here, but we do have transmission problems in terms of siting and permitting, and a lot of times these things are already permitted. So I think, you know, if we're going to be going to a hydrogen economy, what a great way to use nuclear to use that high heat to transform into hydrogen for other uses. It's cleaner, it's greener. There are other uses, I think, besides hydrogen that I think could be like desalination and other things where nuclear could play a great role. And you know, I'm kind of even envisioning, honestly, almost self-contained manufacturing where you might have a small modular nuclear that can serve not just the region, but just, you know, a small industrial complex in and of itself. And, you know, I think there's plenty of space for development there.
Yeah, thanks. And I like it's interesting to hear how you think about it sort of on both sides of the supply chain, both supporting, providing heat and electricity, but also, as you mentioned, providing demand for some of the goods like graphite and so on that you said could be produced in the state. So you mentioned the ADVANCE Act. I think many folks in the audience will know that, but just to make sure, that's the Accelerating Deployment of Versatile Advanced Nuclear for Clean Energy Act. You were a co-author, of course. It was signed into law earlier this summer after passing both the Senate and House with strong bipartisan support. And just before we jumped on, you were saying you were there for the signing. Say a little bit more, if you will, Senator, about the intent of that act and what it'll do for the nuclear sector, but also maybe, you know, why is it for folks in the audience that you think advanced nuclear kind of needs its own bill? I mean, after all, you know, lots of things have been passed. The bipartisan infrastructure law and so on had a lot of support for a variety of technologies a few years ago. And what industry challenges will the ADVANCE Act solve?
Well, I think, first of all, we felt that the ADVANCE Act was really important to sort of move us into the advanced nuclear regulatory and licensing arena. It's a different type of technology. The Nuclear Regulatory Commission has been focused on recertifying or relicensing older, what we think of old nuclear plants, and really hasn't transitioned into this as quickly or as easily as we thought could occur. So in the bill, it is mentioned that efficiency is what we are trying to do here to spur the investment. I mean, everyone knows that these are large billion-dollar investments. If you don't have the certainty in the regulatory and the licensing process and permitting, you know, there's not going to be the investment to follow. So I became interested. Sheldon Whitehouse and Senator Carper were on the Democrat side in the Environment and Public Works Committee. We worked very well together. We kind of ironed out the wrinkles as we actually made legislation like you're supposed to, like compromise and move it through the House and Senate and put it up to the president to sign. certain aspects of it are important, I think, for us as a nation on our national security issues, to make sure that we are the lead here in this advanced nuclear technologies. Personally, I want to see us move quick enough and fast enough to be able to have, as we do have now, the existing superiority in nuclear innovation. We want to keep that for obvious reasons, and I do think that's a national security issue. We also have tried to help in the bill, help the Regulatory Commission hire more quickly, ease the not ease the regulatory burden, because that speaks of overlooking safety and all those things. That's still the primary concern, but it's to improve and streamline some of these regulatory and permitting issues so that these can actually get built and we can see them through to completion. And so those are some of the facets, along with the one facet I mentioned, which is transitioning our brownfield or old coal sites into nuclear.
Mm-hmm.
Those, I think, hold great promise to the heartland of the country, a place where I live, to get that workforce and to get those communities back on their feet. And that's important to me as well. So that's why we decided that we needed to do this. I'm going to say we talked to every stakeholder known to man. We worked very hard to make sure that we were what we were putting in place was workable. We worked with the commission to talk with them about it, as well, the commissioners. So I think we ended up with a good product, and so we're anxious to see it put into use. I mean, it will be emissions free, 24/7, 365 days a year.
So just as a quick follow-up, you mentioned the Nuclear Regulatory Commission and how, if you look back, that's really been focused on the existing fleet, on sort of traditional light water reactors, and this was one of the goals of the legislation. Just quickly, what do you expect to see different? What do you expect to see? You mentioned new hiring and so on. What do you expect to see from the NRC now that that legislation is in place?
Well, we've given them some provisions in there to be able to hire more quickly. As you know, and everybody knows, getting hired into the federal government is an arduous process as it is. I don't think it's lengthy and it's time consuming on both sides, the person who wants the job and the people who need the workforce. So we're going to give them the ability to hire. And the reason I think this is important, because it is a different technology. It is a different, and I think we need to get new eyes on it and make sure we have the focus there. We're asking them to make policy decisions for, as I said, efficient and efficiency. It's mentioned 24 times in the legislation. And so, they are beginning now to start this process. We will have oversight hearings to see how they're implementing this. And I think from what I can see and in talking with the commissioners, this is welcome. Because it sort of sets the rules of the road for them and makes them focus on getting these projects up and running. They talk about they talk about have templates. We'll see.
Right.
We'll see if the template offer actually can happen. Because then you could roll them out a lot quicker. So these are the kinds of questions that we're going to get answered as we move forward.
It's so interesting to hear about that, because that thinking about that personnel piece, thinking about the need for folks with that expertise, as you say, new technology. We haven't built many nuclear reactors that just finished. I know that Southern Company just finished a couple big ones, but we haven't built much nuclear in the past several decades. And this is, again, a new technology. So it's interesting to think about how you all were focused on building up the capacity there of the NRC and the capacity to do that. What about Congress? What's next there? Obviously, you've put a lot into the bill already, but what else needs to be done as you think about building out the advanced nuclear technologies?
Well, as you know, there's a huge, I'm sorry, I kind of stepped on your the end there. I'm sorry about that. As you know, there's a lot of talk about permitting. I've mentioned it several times, whether it's the NEPA process or judicial review parts of the process. There is a bill that's gone through the Energy Committee with Barrasso and Manchin just most recently on permitting. but it's really for energy projects. And, we're talking about industrial use. I would like to see it be sort of agnostic. If we're going to do permitting reform, let's do everybody, renewables, nat gas or hydrogen, however, industrial. Let's make sure that we're on an even playing field here. That's important to me. We've actually, and chips manufacturing is another portion of this. So I think permitting is really going to be critical here. You can't have reliable, and if you look at the power sector, if you're looking at these to generate power, you have to have transmission. You have to have the siting of these transmission to be able to get the power where it's needed or where it needs to be. So I think those are the first things we're going to do, but also the hopes that I mentioned earlier is important because I'm anxious to start this and to see it actually up and running. And so I think it holds great promise for my state. Actually, it could be a real benefit to us.
Terrific. And as you may know, I'm sure your staff knows, and you may know, we've been actively working on that permitting reform piece and
Right.
understand, that the EPRA bill you mentioned, Manchin-Brasso, important step forward, a lot more to be done on permitting. And I like the way you talked about a more holistic or a holistic approach. Obviously, we need to get done what we can get done, but there's a lot to be done there to make sure we can build the clean energy projects that we need to meet our goals. So then just briefly, outside of support from federal government, outside of the permitting reform legislation and so on, what else do you see needed from the broader ecosystem? Obviously, that's outside your day job in a sense, but you see all the stakeholders, you see the ecosystem. What else is needed outside the federal government?
Well, I think obviously the states and private investment are absolutely critical, but we have to have the rules of the road, particularly on the private investment side. You mentioned Southern Company opening their nuclear reactors. Well, I don't have the stats in front of me, but many more years, it took many more years to build and many more billions of dollars. I mean, I think they almost abandoned the project probably 2 or 3 times, and so, we're never going to get the investments. We don't want to see the federal government have to kick in, $500 million on every one of these projects. They should be able to be motivated to, have some kind of, I don't know, profit sector here, or besides the environmental benefit, there's got to be an economic benefit too. And so I think that's important. On the states, I mean, my state alone, we actually banned nuclear. It was not allowed in West Virginia. This was the coal industry. Not allowing any other type of power generation. And so our state legislature 2 or 3 years ago opened our state, and many other states are doing this as well. So, but then you got to have the state infrastructure too, because the state has primacy on some of the environmental permitting parts. So it has to be everybody on it. And then I'd like to see, our energy labs. I know they do a lot of work on this in Idaho. Keep innovating, keep making it. We have issues with supply, obviously, with uranium and all those kinds of things with the geopolitical situation. So there's still a lot of I wouldn't say barriers or hurdles. Hurdles would be a better description. Hurdles to get over, and I don't think this can all be done by the federal government.
So that's a great sort of roadmap for all things that need to happen. We're doing our best to try to mobilize some of that and be part of that broader ecosystem. Just before we leave the nuclear policy world, I'll have one more question for you about the broader clean energy world. But you mentioned the importance of economics here, the importance of making sure that these projects pencil out. I know that the existing incentive, there's a range of existing incentives. Obviously, the Advance Act was huge in terms of helping the industry move forward. We also recently legislation put in place tax credits and new tax support for nuclear. We hear from our companies how important those incentives are to make the economics work out and support the domestic nuclear industry. I'm just curious how important you think it is, and how important you see that continuation of those policies, as well as everything we've talked about to reduce the barriers going forward.
Oh, I think the tax credit, we have the 45Q tax credit for carbon capture, and it's not getting utilized as much as we had hoped. So continuations of that, because I think that drives the innovation and also bring the cost down. because that's one of the complaints on carbon capture and sequestration is it's way too expensive and it's not an economic model. There's others like the 45V, which is, I think, came out of the Inflation Reduction Act, which is supposed to be incentivizing hydrogen projects. We have a hydrogen hub, Appalachian Hydrogen Hub in West Virginia, that's actually going to be using natural gas. And the tax credits are not being fully extended to natural gas because the goal, the interpretation, which I don't agree with, by the IRS is that it doesn't fall within it should all be done with renewable energy resources. And so I think you see there's just a lot of uncertainty as to what full tax benefits are going to be to try to move some of these other projects. So here again, certainty. I mean, we're running up against an election. Nothing brings uncertainty more than an election. And so I think we'll kind of be living in this uncertainty for a while until I think universally these types of tax credits are very bipartisan, very well accepted, except for the interpretation that the IRS made on the 45V. I would disagree with that, but other than that, those are essential, I think, to moving these projects.
Yeah, that point about certainty, Senator, I think is a really important one. We hear that all the time as well from our companies, and as you say, some sources of uncertainty are inevitable, but the more we can do to create that sense of a stable foundation, I think, for the economics going forward. So then let me just close with one more question. We've obviously talked a lot about nuclear for good reason, focused on that. But I'm curious what other clean energy, clean technology opportunities you're excited about, or that maybe we need to be thinking about in terms of greater federal support that can help with the resurgence of advanced manufacturing in West Virginia and in other parts of the country. What else are you really excited about looking at going forward?
Well, we have a couple things going on in West Virginia that I think are exciting. We just we were an old steel company up in Weirton, right across from near Pittsburgh, that area of West Virginia. That's the area I'm from. It was a steel producing area, and there's still a little bit of that going on. But a new company came in called Form Energy, where they're going to be doing longer life, large batteries for power generation, so that backup. And they are rolling that out as we speak. And they just had an open house last week. I was unable to go, but 800 people from a really downturned community came out to see sort of a rebirth of what was a very vital area of that community. And it's contributing to being able to battery store power. And I think that's a lot cleaner, a lot greener. We also have an interesting, Nucor's putting in a new advanced manufacturing, more sustainable, the highest, less emissions steel producing that will ever be. Brand new factory going down along the river in Ohio. Of course, we're right across from Ohio, so the auto industry has a lot of interest in this. But we have an interesting project with Berkshire Hathaway is doing a titanium smelting project again along the river on the Ohio River, and they are putting in a solar farm and it's like I mentioned earlier in answer to the first question, it's a closed system. So the solar farm is going to be powering this titanium smelting, and that's so emissions free. And you need a lot of high heat for that. So I'm excited about what I see because they're able to get workforce. That's why they're coming to our state. We've made it very user-friendly, so to speak. We're very agile at that. So I think those are exciting prospects of how to use green energy and sort of transform a state such as mine, very heavily involved with fossil fuels.
It's terrific to hear about that. A few years ago, you may remember you provided, I think, some remarks for us. We did a roundtable, one of our regional roundtables. It was virtual at the time. It was during COVID, but based in West Virginia, at least virtually, and talked a lot about what the opportunities were for the low carbon transition, the economic opportunities, and it's really exciting to see those start to take place, start to take shape. I'm glad you mentioned Form as well. We one of the other things we're working on is long duration energy storage, and they're part of that ecosystem. So it's fascinating to hear. This is, that's a part of the conversation that
It's
we
happening.
couldn't have had 5 or 10 years ago. And it's really exciting to see it happening on the ground. Senator Capito, thank you so much for joining us. Thank you for your leadership on the Advance Act and on advanced nuclear and all these other clean energy technologies. It's really been a pleasure to have this conversation. We really appreciate your taking the time.
Thank you, Nat, and thank you again to C2ES, and hopefully we'll keep working together to see that we get these things off and running.
Terrific. We'll look forward to that. Thank you.
Bye-bye.
So now we will turn it over to C2ES Industrial Policy Analyst Tess Moran to give a high-level overview of C2ES's recent paper on advanced nuclear process heat for industry, and that will set the scene for our panel discussion. Hi, Tess. Over to you.
Hi, thanks, Nat. And thank you, Senator Capito. My name is Tess Moran. I'm an industrial policy analyst at C2ES. I'll be sharing some highlights from our recent report on advanced nuclear process heat for industrial decarbonization to set the scene for our panel discussion. Next slide, please. So the industrial sector is responsible for about 30% of US greenhouse gas emissions, and that percentage has been steadily increasing since 2010. Thermal energy makes up 2/3 of all energy demand in the industrial sector, and currently the majority of industrial thermal energy originates from fossil fuels. Given that over half of industrial emissions are from thermal energy, advancing key thermal decarbonization strategies in industrial facilities is critical to meet US emission reduction goals. Emissions from low and medium temperature heat are generally easier to abate as a larger selection of clean energy technologies can provide such heat. Applications that require heat over 500 degrees Celsius, called high temperature heat processes, which are responsible for 24% of industrial thermal emissions, need higher heat clean technologies. In addition to electricity production, advanced nuclear technologies can create high temperature heat to meet the needs of more difficult to abate industrial heat demand. Next slide. Advanced nuclear reactors have unique attributes that make them well suited to power industrial facilities. Industrial sites typically need reliably continuous power, as any disruption to energy supply would cause costly shutdowns. Nuclear reactors generate power continuously, making the technology well suited to meet industrial demand. Nuclear reactors are geographically independent, meaning they can be sited anywhere, regardless of sun, wind, or geothermal access. Reactors are capable of operating off-grid, eliminating the need for additional transmission infrastructure to support an industrial facility. Nuclear has a high energy output on a small land footprint, especially new small modular reactor designs. They're compact enough to be promising solutions for facilities that don't have space to build larger clean energy projects. Advanced nuclear designs are modular, allowing customers to only purchase the number of reactor units they need to generate their desired energy output. In many cases, facilities will be able to add additional modules at a later point if their demand increases. So a few opportunities. Aside from zero carbon electricity generation, nuclear reactors can provide heat directly to industrial processes through combined heat and power systems. Developing reactors have higher temperature outputs than traditional reactors, shown in the image on this slide, some reaching about 1,000 degrees Celsius, hot enough to satisfy the heat requirements of most high-emitting industrial processes in sectors such as chemicals, food and beverage, pulp and paper, and petroleum refining. A conservative estimate shows that replacing the current natural gas-fired CHP facilities in the US with nuclear CHP facilities would reduce emissions by at least 75 million metric tons per year, and this number doesn't reflect the excess clean power that would be added to the grid. Reactors can also indirectly decarbonize industrial emissions through clean hydrogen production. When combusted, hydrogen can produce extremely high temperature heat, up to 2,100 degrees Celsius, hot enough to meet temperature demands of all industrial sectors, even those that require higher temperature heat than nuclear reactors are currently capable of producing, such as cement and glass manufacturing. For industries that create emissions outside their fuel use, such as emissions from chemical reactions in the cement making industry, nuclear technologies could power carbon capture, use, and sequestration, or direct air capture technologies to abate these emissions. Next slide. The paper highlights a few recommendations to help overcome some of the largest identified barriers to advanced nuclear deployment. The capital cost involved in designing, siting, and building nuclear reactors is one of the biggest barriers to new projects, though new, smaller reactors should have more manageable costs, both due to their size and their modularity. Additional government support for research, development, and deployment is critical to de-risk and incentivize private investments. As advanced reactor and fuel technologies are demonstrated, growing confidence and lessons learned will likely make scaling the technologies to commercial scale faster and less costly. Increased support for the Nuclear Regulatory Commission will also be key to licensing the technologies at the speed we need to reach our climate goals. Updating the licensing process to efficiently evaluate this new generation of reactors and better equipping NRC staff to efficiently review the wave of new applications coming down the pipeline will be key to successful deployment. Finally, market conditions that incentivize emission reductions, such as a carbon price, would provide a strong nationwide economic signal to switch to cleaner sources of energy. This would make nuclear technologies more cost competitive when industrial facilities select a source of high temperature heat to meet their facility needs. Next slide. This has been a very high level overview of the paper. Much greater details provided in the report on our website. We'll put a link to the chat so you can download the report to learn more. Now I'll turn it over to Doug to kick off our panel discussion.
Thank you, Tess. Now it's my great pleasure to moderate a conversation with two companies that are in a groundbreaking partnership to dramatically reduce energy-related emissions from a large industrial facility on the Texas Gulf Coast using nuclear heat and power. Conventional wisdom has it that nuclear is a solution to reduce power sector emissions, but as Tess just went through, we're going to need a lot of clean, uninterruptible heat energy to decarbonize the industrial sector as well. Just a quick reminder before I introduce the panelists that we will be making time for some questions at the end of the panel, and you could submit your questions at any time using Zoom's Q&A function, which is found at the bottom of your screen. Thank you. Now let's begin the panel discussion. Let me briefly introduce our two experts. Turn on your cameras, please. First, we have Kreshka Young, North American Business Director for Energy and Climate from Dow, a more than 100-year-old global company which manufactures a diverse range of products. And she leads the company's Small Modular Reactor, or SMR, project team. We are also joined by Dr. Benjamin Reinke, Vice President, Global Business Development and Advisor to the CEO at X Energy, a relatively new U.S. nuclear reactor and fuel design engineering company. Thank you both so much for joining us today. Kreshka, I'm going to kick it off to you first. And I'd like to start by asking you generally about Dow's plans as a large manufacturing company, about its plans to reduce its carbon dioxide emissions, and how the company landed on nuclear heat and power as one of its solutions.
Sure. Thanks, Doug. So Dow, like a lot of companies, like many companies really, has very specific carbon emission reduction goals that we've communicated. So, broadly speaking, in the near term, so by 2025, which is just around the corner, we intend to reduce our scope 1 and 2 carbon emissions by 2 million metric tons from our 2020 baseline. In the midterm, by 2030, we intend to reduce those same emissions, scope 1 and scope 2 carbon emissions, by 5 million metric tons versus the 2020 baseline. And then long term, by 2050, we intend to be carbon neutral. So at Dow, we think of that as scope 1, scope 2, scope 3, and carbon and product benefits. So nuclear is a part of that for a couple of reasons, and some of them have been talked about already by Senator Capito and are related really to our need for high temperature, high quality heat to fuel our processes. So in that transition to zero emissions, we're really focusing on 5 things. So one of those is optimizing our manufacturing facilities and processes for better sustainability. The next one would be increasing our use of clean energy and steam. This includes renewables, but also this is really the bucket that nuclear falls into. We're going to invest in transformative next generation manufacturing technologies, develop low carbon products and services, and then also build a value generating Scope 3 decarbonization pathway. So kind of coming back to nuclear, why does nuclear work? Well, in order to power our processes or to run our processes, we need two things. We need highly reliable power, but we also need highly reliable steam. And when I talk about highly reliable, what I really mean is nearly 100% reliability, 99.995% reliability. And so how do we get that? On the power side, there's a few more options, right? Renewables can work for purchased power, combined with some behind the meter grid, generation. You know, we can get very close to that 100% reliability factor. But steam is a lot more complicated, right? There aren't grids of steam out there to supply our manufacturing processes. And steam can't really be transported that far, especially when it's at very high temperatures and pressures. And so nuclear technology is one of the few. There are others, but advanced nuclear is one of the great ones that can provide both the high temperatures that we need, so in excess of 500 degrees Celsius, and also these small advanced reactors are a size that they can be put together, similar to a combined, a cogen facility. They can be combined and stacked, if you will, to meet that reliability threshold that we have, while only having a relatively small amount of excess electricity or steam that needs to be dealt with. So that's really why we've chosen nuclear.
So I would just want to follow up with you quickly here. You know, so that makes eminent sense for Dow in terms of its needs for manufacturing, but I'm really curious how have Dow employees and the community responded to this new idea, this new greenfields deployment of an SMR at the facility? You know, what's it going to be like inserting an advanced nuclear plant right alongside a manufacturing facility?
Yeah, so great question. I think that, well, look, at Dow, our employees and the communities that we do business in are incredibly important to us. Really, they provide us with our license to operate. And so we have tried, and X Energy has been very helpful to us in this endeavor, right? We've really tried to engage our employees early and often with our plans to develop and install this technology at the site. And have provided them with lots of information on the safety of this technology, you know, how it's going to work, supplying our site, what it's going to mean for jobs, all of these kinds of things that are very important to our communities. And we've really, I think, granted them the opportunity to ask us questions. And both our employees, our communities, and other stakeholders have come back with really good questions. And that's completely expected, right? And our job is to make sure that their questions, which are very valid, are addressed head on, and we alleviate their concerns, right? Any project that we do at our sites always comes with concerns and questions from our communities. And so we engage with them the same way that we would on anything else to make sure that those questions are addressed and that they can feel comfortable with how we're moving forward, protecting, you know, not only the environment, but also their health and safety, you know, for our employees and our communities.
Thanks. Thank you so much. Ben, let me pull you into this discussion now. Thanks. So, you know, a lot of people may not be familiar with X Energy. So can you tell us about the company, your SMR technology, and how is this design different and even safer than the current generation of reactors that are operating across the United States today?
Absolutely. Thanks a lot, Doug. And it's always great to have an opportunity to connect with you and C2ES. Thanks for everything y'all are doing in this space to help educate people. I think the report is fantastic, and the discussion so far has been great. Also, always great to have an opportunity to talk with Kreshka in front of folks and tell them about what we're up to. A little bit about X Energy. So we've been around for about 15 years. Our founder founded the company with the premise that he was looking for a technology that was clean, affordable, safe, and secure. That led him ultimately to an idea that's been around for a long time, a technology that frankly has been demonstrated in various form factors, prototypes, test reactors, and even commercial reactors in different places in the world, but never really taken all the way to full commercialization in the US. And frankly, that technology was developed originally here in the US and then brought together with an increased performance in the fuel. And that allowed for this technology to take off at the time that our company was founded. And since then, we've been working with a number of our private sector investors and alongside the US Department of Energy and its national laboratories to demonstrate the ability to make that fuel and design a reactor that would meet the needs of our customers. And that's really come to fruition with the Advanced Reactor Demonstration Program and our partnership with Dow as our first customer. Just a couple things about the technology. So you asked the question about safety, and I think it's always important that we point out that the safety record of the industry today is phenomenal. It is a very safe technology that we have today, providing roughly 20% of the power in the United States. That said, there have been many advancements in technology that allow for an even greater safety case, which ultimately should allow for us to decrease a lot of the reliance that we have today on redundant safety systems, pumps, valves, systems, and components that ultimately provide the assurance that the reactors that operate today will be safe in the long run. And so that for us starts with our fuel. A couple of quick words on the fuel. If you've ever seen nuclear fuel, typically you'll see either a little pellet or a long 12-foot rod. The fuel of our reactor is fundamentally different. This is a fuel pebble, and inside of this pebble would be 19,000 small particles of wrapped uranium. And that fuel allows for an extremely safe performance in the reactor under any scenario, including all accident scenarios, and in perpetuity as a waste form. That fuel is called TRISO fuel. The Department of Energy considers it to be the most robust nuclear fuel that's ever been devised. And it had a long multi-$100 million campaign to demonstrate the safety case of that fuel by performing a radiation test and frankly cooking it at a very, very high temperature. Temperatures that exceed that which the reactor could ever see, even in the hottest part of the reactor in the worst case accident scenario. So we work from there and we design a reactor from the inside out, from the fuel form out, for performance for that reactor. And we rely on the safety case of the fuel and the reactor designed together to ensure the safety of the public and environment. And then that allows us to do some things that today's technologies can't do. You heard about that from Kreshka earlier, and I think the discussion both from Senator Capito and from Tess on the report that you all put together at C2ES. But suffice it to say, these reactors operate at higher temperatures. They allow us to extract secondary side steam that's usable by a customer like Dow at a higher temperature than today's reactors, and it opens up a whole host of use cases that we've never been able to touch in commercial nuclear before.
Thanks, Ben. So we are seeing increasing public support for nuclear. Over the past 9 years, Pew Research shows a 13% increase in Americans supporting expanding nuclear power. On the Hill, there have been, and you were obviously a part of this some of these earlier pieces of legislation, Ben. There has just been year after year, since starting in 2018 with the Nuclear Energy Innovation Capabilities Act, and then in 2019, the Nuclear Energy Innovation and Modernization Act. Then we had the Energy Act of 2020. Then we had the Infrastructure and Investment and Jobs Act in 2021, the IRA in 2022, and most recently the ADVANCE Act, which it should be pointed out passed in the Senate by 88-2 and in the House by 393-13, probably the most bipartisan example of a technology or any subject matter that I could possibly imagine. So there's been a lot of support. Let's go with Ben first. How important has all of this federal support been for this project in particular?
Oh, there's no doubt in our minds that that really, frankly, Inside the Beltway led on a lot of the development of the support for advanced nuclear across the country. People were secretly working in bipartisan fashion in Washington, D.C. when nobody expected it to be done, and we're the beneficiaries of that. And I think it's extremely important that we commend the members of Congress and their staffs for what they've done, as well as the administration's year over year, administration over administration. The support has continued to grow. And I think just to the point you made earlier, Doug, uptick for sure in the United States on advanced nuclear. But I do think that when you look at the overall proposition for nuclear, it sort of fits perfectly in the Venn diagram of economic opportunity and growth, national security and energy security, and decarbonization and climate change mitigation. And that's the one technology that fits squarely within those. It's brought a lot of people together from different opinions and backgrounds. And certainly I think the increased attention on energy security post Russia's invasion of Ukraine has really led to an uptick in interest in nuclear. And I think that's never seen anywhere stronger than actually in Japan, which had the second most significant nuclear accident commercially in the history of the world, just about 13 years ago. And support has ticked over 50% again in Japan for new nuclear, and for their existing fleet as they bring reactors back online because they face the effects of having a lack of energy in their economy. And it's been really fascinating to see that. But I think this is a worldwide phenomenon.
So Kreshka, did you want to add something?
Sure. Yeah, sure. I think all of this is critically important. There's really three things that Dow considers, and I don't think this is just Dow. I think other industrials would agree with you that there are really three sort of non-negotiables in order for industrials to invest in nuclear projects, these advanced nuclear projects. So the first one is really timing. Companies will install advanced nuclear to replace end-of-life assets. So projects need to be delivered along the same timeline, if not the same timeline as alternatives, a very closely competitive timeline with alternatives, and with timing that we can have a fairly high level of certainty about. Of course, budgets are always important. Capital costs have to be really clear, competitive, and sort of consistent. Again, it's really about being able to understand what you're signing up for. And then fuel assurance, right? Customers need confidence that the fuel supply will be there to enable steady operations and again, competitive operating costs. And so I think all of this support that's been developing over the last number of years, sort of when put together, and the things that Senator Capito was talking about as far as permitting reform, and all of these things, I think are really combining to support the development of fuel, to support the efficient movement of projects through the permitting process, and really to help drive the first of a kind capital risks down so that companies like Dow can make the decision to start to develop these projects.
Thanks. Ben, just kind of picking on the Advance Act a little bit in particular, how do you see that impacting this current project, or do you see that as more relevant a little bit further down the road?
I think both. I think that we should not lose track of the importance of the attention that Congress has paid to the NRC and the level of care and scrutiny that have gone into selection of commissioners, et cetera. Today we're the beneficiaries of a commission that's heavily focused on its ability to move into a non-light water reactor, advanced reactor licensing stance. The ability to license new technologies that the NRC has never licensed commercially before. That doesn't just happen overnight, right? It's been a long shift in movement. And I think over multiple commissions, multiple chairmen, you've seen that type of attention and detail. They've certainly grown the capability and the staff. And there's been a lot of attention paid on efficiency and the ability to utilize the underlying safety case of these advanced reactors as the basis for a more efficient licensing review. I think that's been exemplified in the Kairos review of now a couple of different applications that have come in, frankly, with reviews shorter than predicted, which is fantastic. We are working very closely with Dow on the construction permit application for this facility. The Advance Act and a lot of the mechanisms in the Advance Act won't be necessarily in place in order to review the CP for us and maybe not for the operations license. And that's even true of things like the licensing regime contemplated under NEMA, the bill you mentioned earlier, on an advanced reactor licensing framework. However, the attention from Congress, the intention of these pieces of legislation to focus on cost and schedule on licensing are key indicators that we believe that there's alignment up and down throughout government in bipartisan fashion to drive extremely high efficiency in the regulator. That's extremely important to what Krushka just mentioned on the ability to deploy a reactor on schedule. And so we are ultimately benefiting from all of that work that has gone into this and the intention within the legislation. In the long run, I think that it does allow us to look at the ability to scale multiple projects under review for a given technology with different types of application. And I think what Senator Capito mentioned earlier about the ability to bring new smart minds in to grow the capabilities within the regulator, those are going to be key features if we're going to be able to deploy more reactors than we have in the past.
Great, thank you. So one last question from me before I start to ask some of the questions that are coming in from the audience, and thank you for those questions. So I guess just this could be quite a long question or quite a short question, but how are things going so far? What are things moving along, or what are some of the challenges that you're seeing in trying to do this groundbreaking project? And Ben, you can go first.
Sure. I think things are moving along well. It is, as you said, it's not an easy thing to do. We of course all knew that going into the process. Dow's been a fantastic partner to us, and I think it's important that we highlight a couple of key things about this project that are unique. As Krushka mentioned earlier, industrials have a unique view on why to go forward with the deployment of a technology like this. And we have a very high focus on the delivered timeline, cost. And so cost and schedule are key drivers, as well as that assurance on fuel that Krushka mentioned earlier. There's a difference of opinion, I think, or I shouldn't even say opinion, there's a difference of starting point between a traditional utility going forward with a nuclear project and an industrial client that needs a project delivered on schedule and on budget. And so that's led to, I think, our companies being able to learn from one another, in particular for X Energy to learn from a heavy industrial that's delivered a lot of excellent projects on time and on budget. That forms the basis of Dow's competitive edge. And so we have to learn as an industry to do better on schedule and budget than we've done in the past. And I think that is a unique feature that's been to our great benefit as we've worked with the Dow team hand in hand on this process. We always have key supply chain challenges in the first of a kind deployment of anything. And fuel was already mentioned by Krushka. We at X Energy are heavily focused on fuel. We have an ability to manufacture the fuel that we make, TRISO, and it's within a company that we fully own called TRISO-X. But all of the key supply feeders of that are important. We need continued attention from the U.S. Department of Energy to take the dollars that they have and get them to work on the deployment of commercial HALEU production. And that's something that we're waiting on those awards to come out from the U.S. Department of Energy. And it's time to get going. Actually, it was time to get going about 2 years ago, but here we are. And so we have a lot of focus on that and other key parts of the supply chain as well. And it is worth highlighting that nuclear grade graphite is a part of the supply chain that has been kind of moribund across the global sphere. Senator Capito mentioned a key supply chain partner of ours called AGM in West Virginia. And she's been out to take a look at that facility with us. And we think that there's a great opportunity for AGM job growth and partnership globally to support X Energy reactors. So we're heavily focused on those types of key challenges.
Great. Krushka?
So, look, I would echo Ben's comments that I think things are going well, and I think, look, the reality is by well, I mean as expected, right? This is a first of a kind commercial deployment of an advanced reactor with using this technology in the U.S. And so there's every day, every week we experience, I think, our highs and lows, but the key, I think, important message is that we keep making forward progress. We're working towards getting that construction permit application submitted to the NRC and starting to think about, what does the next stage look like after this? What are all of those tasks that we need to do? And so the forward progress continues. I think the teams work really well together, but that, at the same time, we're learning it's a continuous evolving process, right? To learn how we each work. And I think we're getting really good at making sure we're putting the best actor in the different roles and really playing off of each other's strengths. And so everything that Ben said is 100% correct. I think we're really happy with the progress that we're making so far.
Thank you. Thank you. So let's see if we can get to a couple of these questions. If you feel free to pass if it's out of your area of expertise, but Hannah from General Motors has a question around how this project will impact surrounding costs of the grid. I don't know if that's related to grid upgrades for the plant, or how you might interpret that, Kreshka.
Yeah, so look, what I would say is we're implementing this project at a site that today exports a small amount of power to the grid. One of the key things I highlighted before, right, was that this modular technology allows us to build something that meets our reliability needs, but doesn't significantly increase the excess electricity that needs to be sold. However, there will be some additional clean, reliable, firm sort of electricity that does get delivered into the grid on a daily basis. We have the benefit, I think, in Texas with ERCOT being an energy-only market, a deregulated market, and so we will bid that electricity into the grid the same way that we offer everything else into the grid. And so I don't expect there to be a significant change in the prices that are experienced by customers in ERCOT because of this project.
Great. Did you have any comment on that, Ben? Or
I just think Kreshka highlighted something that's really very fascinating for a lot of people that don't know the heavy industrial energy space, and it is highlighted in your report, but the importance of kind of a combined heat and power cogen-like system is the ability to deliver steam locally, but to do that in a way that's highly reliable means some amount of redundancy, and that key feature that Kreshka highlighted in terms of the ability to provide extremely reliable, in our case with Dow, heat, but also potentially for another customer maybe that requires 5 nines redundancy, or 5 nines reliability, I should say, on power, that you could do that through a combination of reactors producing power at the right quantum as well. So, it's a really interesting thing. A lot of people don't know how much power is delivered locally at site and some exported to the grid, as Kreshka was highlighting, through industrials that own and operate, or through independent power producers that own and operate, or even through investor-owned utilities that own and operate those assets on behalf of industrials. So it's a fascinating, different world than you typically think of with utilities.
Great. So here's an easy one to round us out, Ben. How do you plan to manage spent nuclear waste from this project?
Yeah, it's an easy one.
Several people asked that question.
I'll give you the quick answer. So one of the beauties of our fuel type, because of its safety case, is that you're able to do a couple things with it. One, you're able to operate that fuel through the reactor multiple passes, and you achieve a very high burnup. So we're getting a high efficiency out of that fuel. That means that we also burn through a lot of the nastiest radioisotopes. So when the fuel comes out of the reactor core, it's about 10x less in heat load, so meaning the production of heat as compared to traditional fuel. And the combination of that plus the extreme safety case of the ceramic materials in the fuel mean you don't have to put the fuel in a spent fuel pool. Instead, it can go directly into a steel canister for storage. That steel canister is then transported to a building that we have on site that can accommodate the spent fuel from a given reactor for up to 60 years. As we look to deploy this with Dow, we are going to, of course, be continuing to talk to the U.S. government about a final solution for used fuel. And when the U.S. Department of Energy is ready to take that fuel to its final disposition, we'll be able to hand them the steel canister, pack it accordingly, according to DOT rules, and send it off for permanent disposition. But we've designed the reactor to have the ability to accommodate fuel for the entire 60-year life.
Great. Well, thank you, Ben. Thank you, Kreshka, for all of your expertise. Never enough time to get all the questions in mine and the audience. But thank you so much for your participation today, and of course, we wish you the continued success in developing this groundbreaking project. I think everyone is watching and hoping for a successful implementation. Thanks again to Senator Capito and Nat and my colleague Tess for her presentation, and thank you all for your interest in joining today. This will be available shortly on our YouTube channel, and we'll be sending out an email about that to everyone who participated today. Again, thank you very much.
Thanks, Doug.
Thanks, Doug.